Have you ever looked up into the endless sky and asked yourself, are we truly alone? Not just alone in this city or on this planet, but alone in this vast, ancient universe, among stars that have been shining for billions of years, among galaxies that stretch far beyond our comprehension. Our story begins with a question, not one born of fear, but of wonder, of longing, because we humans, we are listeners, we are searchers, we are storytellers. From the moment we learned to gaze beyond the trees, we began asking questions the Earth could not answer. What if out there, in the silence between stars, someone is listening? What if another mind, alien, strange, ancient, or young, looks up at their sky and wonders the same? What if there's someone else somewhere asking, are we alone? This question gave birth to telescopes, to satellites, to missions that dared to leave Earth behind and sail into the deep ocean of space, not to conquer, not to escape, but to whisper across the galaxies, we are here. In this series, we'll follow that whisper, from the early dreams of contacting alien life to the spacecraft we built to carry our voice. We'll journey from Earth's first radio messages to golden discs sent into eternity. We'll ask what it means to communicate with someone who may not think like us, breathe like us, or even see time the way we do. And by the end, perhaps you'll feel what so many explorers felt, that even asking the question makes us a little less alone, because to wonder is to reach out, and to reach out is to be human. This is the story of humanity's loneliest message, sent not to anyone, but to possibility itself. Are we alone? Let's begin. Part 2. Voyager, humanity's flight. In the quiet of the 1970s, as the world spun with its usual chaos, a new kind of dream was being built. Not in a palace or a battlefield, but in a laboratory. 2 spacecraft, barely the size of a small car, destined to leave our world and never return. They would carry no astronauts, no weapons, no flags, just instruments, memory, curiosity. Voyager 1 and Voyager 2, siblings born of science, engineered not just to explore, but to become time capsules, forever drifting in the blackness between stars. Their bodies were wrapped in gold foil to shield them from the fury of deep space. Their hearts, a power source fueled by the decay of plutonium, enough to last decades. They were not fast, they were not beautiful, but they were brave. Each Voyager carried cameras to see, ears to hear the solar wind, senses to feel magnetic fields, and a mind, a computer that remembered commands sent from a tiny blue dot far behind them. They were built to survive, not just distance, but time itself. But how do you send something to the edge of the solar system and beyond? You wait for a moment that comes once every 176 years, a rare planetary alignment. In the late 1970s, Jupiter, Saturn, Uranus, and Neptune lined up like stepping stones. Using a technique called gravity assist, Voyager could slingshot from one planet to the next, saving decades of travel. It was a cosmic shortcut, and it had a deadline, so the engineers raced. Every bolt, every wire, every code line had to be perfect. And then it was time. Voyager 2 launched first August 20th, 1977. Then Voyager 1 followed September 5th, 1977. Though launched second, it was faster, destined to overtake its twin. As the rockets roared and the ground shook, a quiet miracle unfolded. For the first time in history, humanity had sent something that would one day leave the solar system forever. No return ticket, no guarantee, just a promise that someone, somewhere, someday might find it and know that once we were here. Part 3. The miracle of gravity assist. What if you could steal speed from a planet? Not with rockets, not with magic, but with pure physics. This was the genius behind Voyager's journey. A quiet miracle known as gravity assist. Imagine throwing a stone past a moving train. If timed just right, the stone catches a bit of the train's motion, riding the momentum, flung faster than your hand could ever throw. That's what Voyager did. Each planet, Jupiter, Saturn, Uranus, Neptune, became a slingshot, a dance partner, a gatekeeper, flinging the spacecraft faster and farther than any engine alone could ever dream. But this wasn't luck, it was celestial choreography. In the late 1970s, a once-in-176-year alignment arrived. The 4 gas giants lined like rungs on a cosmic ladder. If we launched at just the right time, just the right angle, Voyager could leap from one world to the next, saving decades of time, saving precious fuel, and opening the gates of the outer solar system. But gravity assist wasn't just about speed, it was about precision. Voyager had to enter Jupiter's gravitational field at exactly the right angle, pass within a hair's breadth of its massive pull, and exit not crashed, not lost, but launched forward like a slingshot stone. A single mistake, a fraction of a degree off, and Voyager would drift forever in darkness, never reaching the next planet. And yet, it worked. Voyager 1 used Jupiter's gravity to aim for Saturn, then Saturn's gravity to swing itself upward, out of the plane of the solar system. Voyager 2 took the longer path to Uranus, then Neptune, the only spacecraft ever to visit those distant worlds. Each flyby was a miracle, not just survival, but discovery. And all of it powered not by force, but by falling, by borrowing momentum from giants that never even noticed. Gravity assists the silent hand of nature, turning drifting machines into interstellar travelers. And so, with no more fuel, no wings, no brakes, Voyager flew faster and farther, carried by the invisible hands of planets that whispered only one thing: go. Part 4. From Jupiter to Titan. Voyager 1 didn't just fly past planets. It wandered through wonder and sent us postcards from realms we had never seen. First came Jupiter, the king of the planets, a swirling, roaring giant, so massive it could swallow 1,300 Earths. But Voyager saw what telescopes never could. It flew close enough to watch Jupiter's great red spot churn, a storm larger than our entire world, raging for centuries. It saw lightning dancing in Jupiter's clouds, winds racing at 400 miles per hour, and a magnetic field so large, so strong, it created radiation belts that could fry a computer in seconds. But Jupiter wasn't alone. Its moons, they stole the show. There was Io, bleeding fire. Voyager revealed it was no dead rock, but a living volcano world, its surface bursting with lava. The first active volcanoes seen beyond Earth. Then came Europa, a pale, cracked sphere of ice, but beneath that icy crust, an ocean, a dark, silent sea that might cradle life even now. And beyond that, Ganymede, larger than Mercury, carved with canyons and ridges, and Callisto, ancient and cratered, a frozen memory of the early solar system. Each moon was a world. Each world told a new story. But Voyager didn't stop. Guided by Jupiter's gravity, it soared on towards Saturn. And when it arrived, it found beauty. Saturn, with its golden rings, shining like a crown. Voyager flew through the ring plane, saw shadows ripple across the icy bands, saw new moons hiding within the gaps, shepherds holding the rings together. And then Titan, a moon larger than Mercury, thick orange clouds, no surface in sight. But Voyager's instruments peered through. Titan had an atmosphere, nitrogen-rich, heavy, alien. Scientists gasped. Could there be lakes, rivers, even chemistry like Earth's long ago? We didn't know, but we knew this. Titan was more than a moon. It was a mystery. Voyager had to make a choice: fly closer to Saturn or dive toward Titan. It chose Titan, and that decision sent it away from the outer planets forever. A one-way path for a glimpse at something that might one day answer: are we alone? From Jupiter's storms to Titan's haze, Voyager 1 captured not just images but dreams. And then, with no more planets ahead, it turned its eye back one last time. But that is a story for another part. Part 5. The first glimpse of Uranus and Neptune. While Voyager 1 turned towards the stars, its twin, Voyager 2, continued deeper into the dark, toward the loneliest planets, Uranus and Neptune worlds no spacecraft had ever seen up close. Silent, distant, shrouded in mystery. For centuries, they were just dots through a telescope. But Voyager 2 was about to change that. First came Uranus, January 1986, a pale, cayenne ghost, tilted on its side, rolling around the sun like a wheel instead of a top. Its atmosphere, calm at first glance, but hiding fierce winds and unknown storms beneath the surface. Voyager revealed faint rings, whisper-thin and dark, almost invisible to Earth's eyes, a hidden halo around a forgotten planet. And then, the moons. Miranda, a shattered puzzle, scarred by time, rebuilt by forces we still don't understand. Mountains, valleys, cliffs as tall as Everest, a moon that looks like it was broken and stitched back together by a celestial hand. Voyager 2 moved on to the last planet, the farthest one, Neptune. August 1989. It was deep blue, richer than Uranus, colder, wilder. No one expected it. But Voyager saw storms, huge, raging storms. The great dark spotter, hurricane the size of Earth, spinning at 1,000 miles per hour, and winds the fastest in the solar system, more than 1,300 miles per hour, faster than the speed of sound. This wasn't a frozen planet. It was alive. And then Triton, a moon moving the wrong way or biting backwards, covered in frozen nitrogen, and yet geysers, black plumes of ice and gas erupting from its surface, spraying miles into space. Even here, at the edge of the sun's warmth, the dance of geology continued. It was breathtaking. And Voyager 2, it captured it all. The silence, the storms, the moons that no one had ever truly seen. No spacecraft has returned since. Even today, those images of Uranus and Neptune, they're still our only close-up look. Two planets, glimpsed by a single traveler on a journey no one thought possible. As Voyager 2 left Neptune behind, it crossed the last known border of the solar system and drifted into eternity. Two spacecraft, each on their own path, now alone, but not forgotten, because the story wasn't ending. The story was only getting bigger. Part 6, the last picture of Earth, the pale blue dot. It was 1990. Voyager 1 had already left the planets behind. It had flown past Jupiter, past Saturn, and was now heading toward the stars. Its cameras had done their job. Its visual mission was over. But before shutting them down, one final command was sent. Turn around and take one last look. And so Voyager 1 turned its gaze back across more than 6 billion kilometers of space. And there it was, Earth, a tiny speck, a pale dot, suspended in a shaft of sunlight, barely a pixel wide. No continents, no countries, no wars, no names, just a dust particle caught in a cosmic beam. That image would become known as the pale blue dot, and from that moment, everything changed. Astronomer Carl Sagan, the voice behind Voyager, said these now immortal words. Look again at that dot. That's here. That's home. That's us. Every human being who ever lived out their life on that dot. Every king and every peasant, every teacher and every tyrant, every mother, father, child, lover, and friend on that fragile world, floating in a cosmic sea. Voyager showed us the solar system, yes, but in this final act, it showed us ourselves. It humbled us. It united us. It reminded us how small we are and how precious this world is. After that photo, Voyager's cameras were turned off forever. It would no longer see, but its mission was far from over, because beyond vision lay something even deeper. The sound of space, the feel of the void, the invisible waves of particles and magnetism that still whispered secrets into Voyager's ears. The journey had entered a new phase. Voyager had taken the last photograph humanity would ever see of itself from the edge of the sun's light, and now it would dive into the unknown, into the dark, toward interstellar space. Part 7. Interstellar space, the final boundary. Voyager kept going, long after the cameras were shut off, long after the planets were left behind, and far beyond the reach of sunlight as we know it. It entered a place few had ever imagined in such detail. The edge of the solar system. But what does that mean? Space isn't empty. Our sun breathes. It sends out a solar wind, a stream of charged particles that fills a giant bubble around our solar system, known as the heliosphere. Inside that bubble, we are under the sun's protection. But there's a boundary, a place where the solar wind slows down and finally gives way to the true interstellar medium. That first ripple in the great transition is called the termination shock. Here, the solar wind suddenly drops in speed, crashing into the particles of deep space, like a wave hitting a wall of silence. Voyager 1 passed that invisible wall in 2004, but that was just the beginning. Beyond the termination shock lies the heliosheath, a turbulent, foamy region where the sun's influence still fights to stay alive but is losing strength. Imagine a fragile soap bubble pushing out into a dark ocean. That's what the heliosheath is. And then comes the heliopause, the final breath of our sun, the skin of the bubble, the last whisper of warmth. In 2012, Voyager 1 crossed it, and in that moment, humanity became interstellar. For the first time, a machine built by human hands entered the space between stars. There was no fireworks, no flashing light, no sudden alert, just a quiet shift in the particles, a change in the density, a deepening silence, and a single, invisible line crossed. Voyager 1 was now outside the solar system. It was still hearing whispers of our sun, but more faintly, now as if from another room, another world. It had reached a place no one had ever been. It had touched the boundary between us and the rest of the galaxy, and it was still listening, still sending signals home, still carrying our name, our hope, our story across a void so vast that even light trembles to cross it. And it wasn't alone. Voyager 2 would soon follow. Part 8. Alien message. From Pioneer to Voyager. Long before Voyager left Earth, there was a question floating through the minds of dreamers. What if someone out there finds it? What if in the silent abyss between stars, someone discovers our lonely spacecraft, drifting like a message in a cosmic bottle? And so humanity decided to write a note not of fear, not of war, but of peace. That idea began with Pioneer. When Pioneer 10 and 11 were launched in the early 1970s, they became the first spacecraft headed toward interstellar space, and on each of them, NASA placed a plaque, a golden tablet etched in silence, drawn not with letters, but with symbols. It showed a man and a woman, naked, open, peaceful. It showed the spacecraft's origin, position in the galaxy, and the path it took. Simple, humble, a whisper. We were here. But with Voyager, humanity dared something far greater. This time, we didn't just send a plaque, we sent a record. The golden record. Not just metal, but music, images, voices, emotions. It was a time capsule of Earth, a 12-inch gold-plated copper disc, carefully engraved, coded with analog data. It carried greetings in 55 languages, from hello in Hindi to peace and happiness in Chinese to the heartbeat of a human being. It played the music of Bach and Beethoven, but also of a Navajo night chant and the rhythm of Senegalese drums. It showed pictures of our homes, our families, our DNA, our chemistry, our mountains, our oceans. It captured the essence of who we are, and on its surface, etched in metal, a map, a way home, if they ever wished to find us. Carl Sagan called it a bottle cast into the cosmic ocean, on the chance that someday, somewhere, someone might discover it and understand. Unlike the Pioneer plaque, which was silent, Voyager's record could speak, sing, whisper. Not just we were here, but this is what we felt while we lived. It was the most hopeful message we've ever sent, not because we expected a reply, but because we wanted to be known, not just by aliens, but by ourselves. In the act of creating that record, we looked inward at Earth, at each other, and asked, what do we wish to be remembered for? Voyager still carries that golden disc, billions of miles away now, a tiny craft in the dark, humming gently, with Earth's story folded inside. If it is ever found, it will be the first artifact of humanity another intelligence might ever see. And perhaps they will smile, or wonder, or cry, just like we do when we look up and imagine we're not alone. Part 9. Can aliens read this? We sent it. The golden record, a message of music, math, love, and light. But now, the question echoes back to us. Can they read it? Can they understand it? Can they even recognize it as a message? Because imagine you are not human. You don't see like us, don't hear like us. Your logic, your senses, your reality might be utterly different. So what do you do when you find a strange golden disc floating through the emptiness of space? Would it look like a tool, a weapon, a ritual object, or maybe a puzzle? Let's pause and look at what we gave them. On the front of the golden record is a series of diagrams engraved in the language of physics and mathematics, the only language we believe all intelligent beings might share. It tells how to play the record using pulsars and hydrogen atoms as cosmic reference points. It shows how to build a stylus, how to decode the grooves, how fast to spin it. It even explains where we are in relation to 14 pulsars each,